Hello, grade 11. So this week we had our QP, and then we started with a new lesson, which is chapter 6, generalities about functions. This is also a reminder of the lesson that we have taken last year. So we are going to remember the important concepts that we have learned last year in order later to start with a new lesson, which is limits at a point or at infinity. So let us first remember together. First, we're going to remember together how can I find the domain of definition of the function. We're going to revise the parity of the function. Okay, let us start. First of all, as a definition of a function, how can I tell that this is a function? A function that has the image and antecedents. Okay, and for every image, we have an antecedent. Let us remember together how can we find the domain of definition. The domain of definition of a function, we can find it in two ways. It's either graphically, so using the graph itself, or we can find it. Let us remember first, how can I find the domain of definition graphically? As you can see here, we have this curve. It started at -2 and it ends at 3. So the domain of definition of this function is from -2 to 3. Now, what if I don't have the curve and I need to find the domain of definition? Okay, you have to know that in domain of definition, we have three cases. We have the polynomial, okay? So we have, I'm going to write them. So to talk about domain of definitions, okay, domain of definition, we have three types, okay? So we have three types of functions. The first type, we're going to talk about it, is the polynomials. Okay, so we have the polynomials functions. The polynomial functions, they have no constraints, which means that all numbers are accepted. So the domain of definition, we can write it in two ways. We can write R, R means all the numbers, or we can write minus infinity plus infinity. When I say minus infinity plus infinity, means that all numbers are accepted. Now we have the second type of fraction or a polynomial, which is the rational function. What's the meaning of rational function? In rational functions, we have p of x, okay, p of x over q of x. So we have polynomial in the numerator and polynomial in the denominator. What's its constraint? So what does it have as a condition? As a condition, we can say that this function cannot have q of x equals to 0. Q of x shouldn't be 0. So I take a condition q of x different than 0. Okay? Now I will give you example for each case. The third case, or the third type of function, we have the irrational function, or in another word, the radical ones. If we have radical, for example, p of x. What's the condition for the radical? We know that the radical is a positive operation. So everything inside the radical should be positive. So we take a condition that p of x is greater than or equal to 0. Okay? So in this case, we have three cases. How do I solve them? Let me take the example that we have solved in class, which is example 1 in the book, exercise 1 in the book. Okay, this is exercise 1. You are asked to find the domain of definition of the following functions. Okay, look at the first one. The first one we have f of x equal x to the power 4 plus 5x cubed plus 7x minus 11. This is a polynomial function. Then the domain of definition of this function is R. What's the meaning of R? Directly it's R or minus infinity plus infinity. Let us take the second example. We have f of x equals x over to x minus 5. This is a rational function where we have a polynomial over a polynomial. How do I solve this? We take the condition that the denominator shouldn't be 0. So I'm going to solve it. 2x minus 5 cannot be 0. Okay, then x cannot be 5 over 2. What does that mean? All the numbers are accepted except 5 over 2. So the domain will be minus infinity, sorry, 5 over 2, union 5 over 2 plus infinity. Sometimes you will see that it's written like this, all the real number minus 5 over 2. So both writings are accepted and you can see them in your book. So they use the two ways, okay? Oh, sorry, here the plus infinity is open. Okay, so this is the second case, which is the rational. I'm going to take another example, which is, let us take, for example, number 4. This is an irrational function where we have to take the condition that everything inside the radical should be positive. I'm going to solve it also here. So I'm going to take x squared minus x greater than or equal to 0. Okay, how do I solve this? We take x common, so x minus 1 greater than or equal to 0. So we have two solutions, x equals to 0 and x equals to 1. When I have second degree inequality, always remember that you have to do a table, 0, 1. But now I can do it only one time because I have two roots. Here A is positive. So same, opposite, same, plus, minus, plus as a sign. We need it positive, and equal to 0. So I'm in this interval. So what's the domain in this case? It's minus infinity, 0, 0 closed, union, 1 plus infinity. So that's our domain of definition. Okay, so everything between 0 and 1 is not accepted. You cannot see a curve between 0 and 1 because it's rejected. So that's a quick revision for the domain of definition of a function. Now, if you look at the second exercise, now I'm going to erase everything. Okay, let us go for the second exercise. In the second exercise, we've already have a figure and we need to find its domain of definition. So you look at the curve, it started at minus 2.5 till 0.5, it stopped. Then it started again at 1 to 3. So the domain of definition, as you can see, is from minus 2.5 till 0.5 closed. Okay, union, then from 1 to 3, the 3 is open. So if you have a figure or you have a function, in both ways you can find its domain of definition. So I wish that it's clear for you. Of course, you can practice the other parts. Now, also, we've talked about the parity. So let us go back to the parity of a function. What's the meaning of the parity of a function? The parity says a function, it could be even or odd or neither. But if it's odd or even, it helps us a lot in our drawing. So let us read this. What's the meaning of, I'm going to highlight this. Okay. Okay. So f is said to be even. So when I say that a function is even, if we have f of minus x is equal to f of x. Okay, so f of x equals f of minus x, that this function is even, and it admits y-axis, axis of symmetry. What I'm trying to say that if you have an even function, sorry, I'm going to continue. What I'm trying to say that if you have an even function, it's enough to draw part of the function then the other part will be symmetrical according to the y prime of I. So again, if a function is even, okay, then we have f of minus x equals f of x, and it admits y-axis as an axis of symmetry. Also, if we have an odd function, then f of minus x equals minus f of x, and it admits the O, a center of symmetry. So it has a center of symmetry. So if you have here a function, and it's an odd function, then you can continue the figure in this way. So it has O as a center of symmetry. Look at these figures here. Okay, look at the first example. The first example is an even function because as you can see here, we have the y-axis as an axis of symmetry. And here we have an odd function because as you can see, the center O is a center of symmetry. So till now in class, we have talked about the domain of definition and the paradigm